So for this tutorial, we're looking at using the linear scale factor. So I've taken some questions from the practice questions, which you can see on the OneNote. We're going to look at finding a missing side if we know the linear scale factor. So looking at this first one, we've got two similar shapes. So if we're told that they're similar shapes, we're thinking we're getting a scale factor, finding a missing side. So two similar shapes, state the scale factor from left to right. So we're going to start with doing the linear scale factor. So I'm doing question 1A. So the linear scale factor is the new length over the old length, or the new length over the original length. So looking at what we have here, we need to find two lengths that match. So you can see that this height is going to match this one x, and these two at the bottom, the 4 and the 6, they match each other. They are this has been enlarged, and that one matches the one at the bottom. So we're going to use two that match that we know both the lengths. So we know the 4 and we know the 6 for this one, so we're going to use both of them. Now, the new one is the one that's been enlarged. So as you can see, we started with this shape, we enlarged it, so our new length here is 6. And it's good if we think the new one is the one that we've got a missing side on. So our linear scale factor becomes 6 over 4, which is 3 over 2 if we simplify it. So we have our scale factor, which is the first part here. We're going to state the scale factor from left to right. Calculate the length marked x. So x is going to be, so our x here is going to be the original length, or the old length, 9, multiplied by the scale factor. So you can write that out if you want, the old length multiplied by the linear scale factor, if it helps you remember. These words are not necessary. You could just go x equals 9, the one that we started with, and it got enlarged to x, and it got enlarged using this scale factor that we've used here. So 9 times 3 over 2. You can put that into your calculator. 9 times 3 over 2. So our new answer, 13.5. So the new length becomes 13.5 centimetres. Right, I'm going to do part B, and then I'm going to look at one similar triangles question, and then you can try some yourself. So for this one, this time we're going from this original shape, and it's being reduced in size. So we're expecting now the smaller number to be on the top. Before we had 6 over 4. If we had been reducing it, it would have been 4 over 6. Here, we're going from a large shape to a small shape, so we're expecting a reduction scale factor. So for part B, the linear scale factor, new over old. Okay, our new shape is this one. This is the one that's been reduced. So it's going to be 14. That's our new length. Again, sorry, I found the pair that match that I know. I know the 14 and I know the 21. So it's going to be 14 over 21. We can divide the numerator and the denominator by 7. So it becomes 2 over 3. So this time our linear scale factor is 2 over 3. So to find x, this missing length here, this time x equals, we find the one that matches it, which is 30. And we multiply it by the scale factor, 2 over 3. We could do this non-calculator as well. Remember, divide by the denominator. So 30 divided by 3 is 10, multiplied by 2, 20. So our new length here is 20 centimetres. So that's your basic process for finding a new length using a linear scale factor. I'm just going to look at one more question now. This time we're going to look at similar triangles here. So this says calculate the length of the side marked x in each diagram below. So if you get one of these, I would say the first thing you should always do is just draw a sketch of the triangles. Now, if I was to mark on here which ones were similar, this angle is going to be similar with this one here, the two that I've marked in red, because they're opposite. They're vertically opposite each other, so they're going to be the same. Now the other ones that are going to be the same here, this one in this corner, this one that I'm marking green, we can see that these are parallel lines, so we're looking for alternate angles, looking for that sort of Z shape. And so that one's going to be the same as this one here. And finally, the last corner here, again, we can see that Z shape for the alternate angle is going to be the same as the one here. So once we've got that, we can actually draw these out as two separate triangles so that we've got it more in a diagram that looks like the ones that we had before, just side by side. So you can just draw a quick sketch. It doesn't have to be anything too specific. So I've drawn one. I know that that's 20. That's all I really need to draw. And now that's this one here down at the bottom. Now if I was to turn this one upside down so that I've got the same ones matching. So the larger one, I know that that is 54 on the bottom and 36 here. And our missing side is this one down here, X, which I'm going to mark here, X. Now this looks a little similar to the ones we've just done now because we have two similar triangles side by side. We need to find the missing length. So we're going to start with the linear scale factor. Linear scale factor, new over old. So this is our new shape really, even I've drawn it on the left because this X is the one we're missing. We've gone from this large triangle to the small one, so we've got a reduction scale factor. So 20 and 36 match each other. 20 and 36, which we can simplify by dividing them both by 6. By 4, sorry. So 5/9. Divide them both by 4, we've got 5/9. This is our linear scale factor. We can now find X by doing the original length, which was 54, and multiplying it by the linear scale factor, which is 5/9. Again, we can do this with a calculator if we need to do. 54 divided by 9 is 6, multiplied by 5 is 30, so the new length is 30. And if I just look back, it was in millimetres. So 30 millimetres. And that's your new length. Right, you can try the rest of the similarity practice questions now.